Shams, actually, you're sharing the presentation now?
Yes, that's right. Good evening, everyone who have joined us for the C-Cube Chartered Engineers Career Chat event. It's 1:06 here in UK. We'll give a couple of minutes for other participants to join as well. So in about 2 minutes time, we will start our presentation and our speakers. Stay tuned. Okay, without further ado, hello everyone and welcome to C-Cube Chartered Engineers Career Chat event. My name is Shyam and I'll be your host for this evening. This event is an opportunity to hear firsthand from 3 different speakers who are chartered engineers and at different stages in their career journey. You can kickstart your registration with an accredited institute under Engineering Council or even start your CEng journey and reach your professional goals. We will learn about the application process and different competencies within the Engineering Council framework. Here, useful tips also to debunk common myths about professional registration. The format of this event will be a 20-minute presentation from each of our speakers. They will take us through their career journey, also through their allocated competencies of the CEng. Will be followed by a 15-minute live Q&A with the audience, obviously. Before we go ahead, we have a few house rules we have to go through quickly. This evening, this event will be recorded, so those who are unable to attend this event live and those who are looking to come back to it can do so in future, and it will be posted in our YouTube channel. Please use the Q&A function to prepare your questions to the speakers. We do motivate and urge our audiences to please place your questions, anything that all matters within the CEng registration. This webinar should take around an hour, 20 minutes to 30 minutes, and we will expect and we'll try to keep it in time. So this is the agenda for today's event. We've just gone past the event start, ice break and introductions. Will be followed by the first speaker, Amit Kumar Sahoo. Not breaking any surprises here. He will introduce himself to you, followed by Silva, who is also another chartered engineer from the automotive field, followed by Timothy Arkane, who's also a chartered engineer. Followed by a live Q&A with the panelists. We'll have some takeaways at the end and a final key announcements by the London Young Professional Network, and followed by an event close. So without further ado, I would like to request Amit Kumar Sahoo to take over, and over to you, Amit.
Hello, thank you for this opportunity for letting me to engage in this event. And I'm Amit Kumar Sahoo here. I actually am a chartered engineer. Just 1 second, I'll share my screen here, the presentation. Okay, hope so it's visible now for everyone. So actually, I'm an electrical engineer. So that's why this dramatic background from everyone. Although we don't actually use such kind of arrangements due to going green these days for net zero emissions and stuff, to make technology more sustainable. A bit about me myself, I would say that I frankly have not been into sustainable engineering. I have been into conventional engineering, which is crude oil extraction and refineries and coal-fired high voltage substations, as much as you can pollute the environment, to be frank, for the last 13 years or more. And having pursued a career as a detail engineer in electrical engineering, I have chosen to pursue my master's here. Presently, I'm a student pursuing my master's in electrical and electronics engineering in University of Glasgow, and for a year now. And I acquired my license by 2020 May, 2 years before, and it was only then it encouraged me to move ahead further to strengthen my credentials and streamline my expertise with further foundation as per UK standards. So I'll just give a short, layout of what it actually means to me. Uh, so for me, like as I said, after 13 years of experience, I have been, pursuing my master's here. And for the best tip that I could say that you're like the network, actually, it's massive in IIT. It has different verticals in different domains, and to whichever domain you belong to. For instance, I said that I belong to conventional energy transmission and distribution through high voltage substations. And IIT has a very big network of regulations to be followed based on the standards practiced in Europe and UK. Basically, what actually UK standards do is have a pretty much elaborate set of amendments to the European standards, which we call it as IEC. If you move over to the far west, it is American. We call it as ANSI, and for here in the Middle East and Southeast Asia and all the rest of the world follows a wide globally accepted standard, which is Electrotechnical Commission, International Electrotechnical Commission, which is IEC. And to just cut short, it's actually when you follow the British standards, the authority that regulates the British standards, one of the authorities is IIT. And also IIT is just not for the industrial practices, it's also an accrediting institute for these setting up the standards for the universities themselves who offer the relevant courses to study for the people. For instance, University of Glasgow is accredited by IIT, so it has to maintain this standard based on the regulations of IIT as well. So how it helped me actually is I have now having, as I said, I had experience in IEC standards. So how do I relate to UK? Is to further streamline myself, know a bit of. For me, frankly, it was a myth of how to attain this licensure. Being outside UK. Now, people who are in UK, for them, there are many organizations who internally promote the candidates working in the company to move up the ladder after a few years of experience, say for 3 or 5, based on their roles and cadres. But what about people outside UK? For them, we do have local chapters outside. So I wanted to align myself based on the UK standards, based on the British standards, regulations, and these standard practices followed here. To be even able to be accessible to the employment market here, to prove your skill set, to be aligned with the UK spec, what we call a standard for professional engineering competence. And as you can see, my career timeline, as I explained before, I have been working for around 13 years from 2006 after my graduation. And the myths that I have listed here is that you should, sorry for starting from the bottom up, actually the fourth one which I mentioned, you should be only within UK. I wanted to emphasize on that, that it's not required that you have to be inside UK, can be outside. As a living example, I'm saying that. And then there is only one particular format for seeking chartered engineering license. No, you can be a technician, TMIT, a technician member, and then promote yourself all the way up during the application. And there are various formats that you can apply for, as long as it is endorsed by your peers and superiors within or from outside the organization that you have worked for or gained experience. And you always need another chartered engineer to support your application. That again is a big one. You don't have to know another chartered engineer. You can pursue this license based on endorsement of your skills by the organization that you're working for within, provided your superior approves of your skills while you present the request for supporter as a supporter. And you need a particular years of work experience. No, it's not like, as far as my opinion is concerned, as long as you can satisfy with a few years of experience the 5 clauses of UK spec, starting from A, B, C to D to E. As we go on, we'll move on that. I believe the competency class A is the one which you're going to cover in this presentation. And there are a set of other subclasses as well, starting from B, C, D, and E. As long as you can satisfy that, you are eligible to apply for membership and then for license. So the definition of commitment that here I can give is the core commitment. What I can put in a few words here is to abide by the legal and regulatory framework of the organization that the audit process are conducted for all the engineering deliverables or the construction activities being carried out in different energy or other banking sectors or even building, or starting from a variety of industries. You can extend the whole engineering and construction division through different verticals, starting from water infrastructure, aviation, road infrastructure, metro rail projects, refineries, oil and gas, mid and downstream, crude oil extraction, minerals, metals, mining, wherever you go, whatever we do, whichever industry it belongs, IT itself has a comprehensive codes and practices to be followed, which again is aligned with the British standards, and which again is just a sort of more refined amendments of the IEC standards itself. As you move on, I can tell that. So the importance, as I said, the global standards, IEC, ANSI, and IEEE, or even the German standards, DNV, GL, the implementation of those standards in the UK when it comes to UK. IIT is one of the institutes which regularizes these standards based on the British standards. There are other institutes as well. So since we are from IIT, we'll keep it to that. So the benefits of being a member or a part of IIT is to be able to accessible to the wide database that is present in the IIT framework as you join the network, talk to different professionals in different domains. It doesn't necessarily mean that if you are, say for instance, an industry which belongs to completely different, which is mining of nickel, bauxite, and cadmium, which mostly isn't in UK, it's mostly in Australia, but here in UK, it's rare. But even if you say that even if your industry is rare, you will find someone who has a certain amount of work experience and who has been involved in IIT. So that wide the network is. Actually, you can always reach out to even those technologies which are outdated. Say for instance, the relays in the switchgear and automation for power transmission has been upgraded tons of times now. So, but there are still technologies which follow the conventional replacement of custom-made technology, which follows the robust old technology as well. You can find people who have dealt with those old technology also. Um, and also a pathway to the professional registration. People who are there to guide you, people like me and everyone there, how to apply, as long as you are identified as a skilled person and you can satisfy the competences in the clauses as mentioned by UK spec. Um, okay, what is actually C engineering? Um, Basically, it's a professional license awarded to the registered individuals who, as I said, successfully complete or identify their professional skills as described by UK spec. It has to be vetted, endorsed, and evaluated by the support license holders and the panelists from inside IIT. For that, which one of the most crucial part is the development action plan, the DAP, which is the identity of being professional registered. And there are certain criteria to meet the DAP. As we move on, I will try to explain that. So what is DAP is actually, it is the one which directly explains and elaborates directly routes to the 5 subclauses of the UK spec. It's actually a commitment to exert one skill in a layout, or in a nutshell, what is actually his current role and competency, what is his strength and what is his weaknesses in different verticals uh, inside the domain that he belongs to. Say, for instance, he has been a manager now, and he's handling different responsibilities, and over a period of time his responsibilities has accrued and he has got promoted to next level, but he still has some room for improvement and scope for improvement. So even those can be brought into the development action plan. Apart from that, for the scope of for improvement, there are other areas like what his ambitions are to promote himself to even higher positions inside the organization. Even those can be inculcated in the DAP plan. As we move on, actually I intended to keep this DAP inside this presentation, is because it forms a really crucial part to give a wholesome scenario of what exactly the whole registration means, the process means actually through DAP. This is actually the crux of the whole thing. So actually, moving to the knowledge and understanding as identified by subclause A of UK spec, what does it mean? As I said, there are 5 subclauses running from A to all the way to E, each having their own subclauses, again, like A1 and A2. As we move on, you will have even more subclauses towards D and E, up to even 5 subclauses each. So it's a big layout actually of skills that you need to justify while through applying. So today we'll be covering just the skill sets A and A1 and A2 defined to the subclause A. So what actually A means is that it looks for the evidence that the candidate has the know-how to do the job, which means he basically he actually satisfies the basic requirements, and was certainly, may or may not, which is second part of the sentence, I would not fully endorse that, although it means that was able to go beyond the immediate requirements to solve a problem. It actually may be limited sometimes. To be honest, everyone in the industry doesn't actually get scope for that kind of improvement to go beyond their defined confined responsibilities, but sometimes there is a scope for improvement, and he must have taken it, added more roles to his career while working. So, but essentially, he actually has the basic skill set criteria to do that, and that's verified by the one which is A1, which is maintain and extend a sound theoretical approach, which means that you have good command of using application knowledge for the standards and the codes and practices you are working in the particular project. As I said, there may be British standards, IET regulations, and IEC standards, but then there are the client specifications as well, depending on the job that you need to perform. So, and the client specifications are particularly drafted for specific applications, like say, for instance, you are working in a Shell refinery. They may follow IEC, but Shell itself, they separately have design and engineering practices, which is a further amendment to IEC, even after British standards. So there are amendments after amendments to take care of specific requirements. And also for the matter of safety and longer duration of the equipment, durability of the equipment, sorry, to increase the lifespan and the profitability, and to also avoid the lost time incidents. These things actually add more standards and specifications. So the person should have maintained that kind of theoretical sound approach to have a good command of understanding of all the specific standards that are used inside the organization where he is working, and then engage in creative and innovative development inside any company you work for. As you said, the revenue planning, cost cutting, things, ways to improve the economic approach to solve a particular issue or to carry out a particular installation of engineering practice. These always are in a constant demand in any industry. So an engagement in that perspective is required for satisfying skill A2. So to move on, I will just show you the rest of the other subclauses, which are a part of UK spec, which is not covered in the section. So don't worry about it. I'll not go through that. Not taking much time, but I'm just presenting that. Take a minute to just see what it is there. Like B is application to practice further, extending your knowledge from theoretical understanding to the practice. And C goes further beyond just leadership. D is something which is interpersonal skills, and E is professional conduct, which is more into ethical standards. So actually, I want to a little bit give a short, overview of an experience-related example of what actually A1 might look like. As I said a while back, that you might have the theoretical approach, but in theory, you may have learned many things inside the university. But when you come to the organization, there are again specific trainings provided, specific workshops or internship that you might have gained in any engagement before joining the organization, and you would have gained some software knowledges and the theory behind it. But that's again just limited only to theory unless you practically get involved in any particular project to solve a real-time situation or carry out a particular task in an engineering contract. So these, for instance, as an electrical engineer, there is a software package called Electrical Transient Analysis Program, ETAP. So if you have a sound up theoretical knowledge about it and have gone through a training through a particular module in that software, there are like these listed modules which I have listed here: short circuit analysis, load flow, motor dynamic startup, relay coordination, arc flash analysis. These things are the modular material of the software that you need to understand before declaring that you have a sound knowledge of the theoretical approach of the software. But then if you go to A2, it's actually innovative design. Based on what you know, how can you apply that to innovative example in design and development? I've shown an example here as what I had done. I just straight away jump into the example to cut it short. That what I had done is in a company called as ABB, Asia Brown Poverty. It is actually mostly into switchgear and automation. So there is we have something called to improve the power quality. The most widely used term is power factor. The bills that comes to your house, the electricity that you consume based on the quality of the power, how much losses can you incur depends on the power factor. So there's an equipment which does that. But then how innovatively can you understand that equipment to have automatically correcting the power factor, to improve that power factor by adding a few capacitor banks by themselves, which is done by the relay. Now, this set of application, although you know how a capacitor bank works, then you have further beyond went ahead and then implemented an automatic setting which does that by itself in real time using the APFC scheme of ABB Abacus, even at a high voltage of 6,600 volts. So that's actually something that is actually implemented. It's already, the technology is already there by ABB, but what you are doing is changing the relay settings inside that in a manner that it selects the particular capacitor banks to correct that power factor automatically. The equipment doesn't actually do by itself. As the other example is like for a solar power project for utility consumption, how to bring an off-grid. When we say off-grid solar, it means that off the grid of the power panels you have batteries. So actually, why I'm trying hard to further emphasize on these kind of examples is that the more sophisticated the technology goes, when you deal with difficult systems like batteries, the maintenance issues with the batteries increases a lot. While in switching components and when you invert it back to the alternating current, things like that, a lot of harmonics get involved. How do you automatically manage those things? So more into automation when you design and develop that to make it more innovative is what is actually a part of A2. There might be situations where you might not be involved in much of sophistication. There might be simple solutions as well already there, but it is just about the engineer who has connected the dots at the right time. Say, for example, the number 3, which I've mentioned, implemented a fault current limiting methodology, which means that I'm reducing the short circuit current inside a switchgear by using a particular device called limiters, IS limiters. Now, this is already there. It's not something new. I'm not actually researching or doing something new here, but you are able to design and propose an innovative solution during the design phase of the project, which actually wasn't there in the front end design presented by the consultant of the client. But then you, as an contracting engineer, are proposing this kind of a solution which is out of the box of the front end engineering design, which is called the feed design. So I'm just being more specific how things can matter while you're carrying a normal, executing a normal engineering contract with your company, but you can still go out of the box and then propose a different solution to be innovative. Even that can happen. So it could be simplistic, but it's actually innovative. So that's what comes under A2. So I would just show how did I did that. So this was what I was explaining as show to just show. Just I will not explain it further, but just showing it. How the relays can be automated inside the capacitor bank, which is shown here as part of the A2 skill, how an A2 skill might look like while saying that, okay, you did something innovative, and how did you manage to do that? How did you bring in those relays to automatically function? So designing the scheme for that, and then I have not actually presented the whole scheme for that because the limitation of the pages here and the time. But this is just a small example for that, and just want to add something more. Further moving to the most crucial part of this whole association as a membership after pursuing your licenses would be the DAP itself. Which looks like this actually. So what actually is your jobs, roles, and responsibilities look like from date to date in different organizations, and what particular tasks you might have carried before, and what is actually your development plan. In what area do I need to improve my performance, and then to learn, what do I need, what particular item I need to learn or seek training for. And when actually, frankly speaking, when you prepare something like this so organized and present that into your currently working organization as well, they take it actually very encouraging. So they do encourage this kind of well-defined layouts, when you can present this to your internal organization as well, and say or something similar, and say that this is part of my DAP, and these are all the software packages that I need to, or the trainings that I need to require to carry out my skills even better. And then this is what I intend to achieve, and what likely more other resources that I would require, and what is the deadline for that. So it can be throughout your phases, whatever you have carried on. It can be, and this is actually a general DAP. It actually covers all the clauses from A, B, C to D to E. So it is not just A or B or C. If you see, I believe, sorry for going back, and I think skill number C is commercial leadership, also technical leadership, which means that if you're going to be a team leader of a particular project, guiding other engineers, also interpersonal skills, even that actually covers inside that, apart from your A1 and A2. And then that would be it. Actually, this is just one. I wanted to show how the DAP would look like. Sorry if I've taken more time. I would like to pass on to the other members. So.
Thanks, Amit. Thanks for that take through on your experiences and the CEng itself. It was in fact really eye opener when you took through all the DAP, and it actually got me back to when I was applying the CEng, in fact. But hold on, as a speaker. Thank you so much. I think I'll, without much ado, I will pass on to the next speaker, who is Robert Silva. In fact, for Ravit, I have offered him to share the presentation. So if you could bear with me for a second. And audience, thanks for being patient. Please do post your questions, if at all there is any, in the Q&A functionality, and ask us any questions so that our experts here can actually give you a good idea of what those are and how you can get away with it. Right, so sharing the screen now. Ravit, if you could, on your video as well. And
hi,
after you.
can you hear me?
Yes, I can.
Am I audible to everybody? Good evening, everybody.
Yes, Ravit, your video is not visible. If you could
it's been disabled. I don't know. I can't. I'm trying to. I think you need to allow access or something. The host has disabled the video.
Sap, could you please allow Robbie on the video, Sap?
Give him 1 minute. I'm trying to.
No problem. Robert, in the meantime, if you could start off, if you could see the screen as well.
Yeah, perfect. Yeah, hi. Good evening, everybody. I'm Ravit Silva. I'm coming to you all the way from Sri Lanka, beautiful island. So without further ado, I'm not going to be talking very much about the technicalities and the nitty-gritties. So I just want to tell you about myself and how I got the professional registration. So if you can just move on to the next slide. Shyam? Yeah, so just a brief introduction about myself. I graduated from Kingston University in Surrey in automotive systems design. And I worked as a manufacturing engineer at McLaren Automotive. And after which I joined Delta Controls as a project engineer. And then I came back to Sri Lanka and I worked as a service engineer in the automotive industry for the last 10 plus years. So going forward to the next slide. So, yeah. So since then, apart from my employment, I've been an entrepreneur. So I started a company called Car Station Limited. It's a SaaS-based automation platform. It's a software as a service company. And Rodasi Private Limited, we give design and develop sustainable mobility solutions. And of course, Q Technologies, it's a R&D automotive hub. It's supposed to be transforming the Sri Lankan landscape into manufacturing. And on the industrial social development side, I have been included in most of the ministerial portfolios in Sri Lanka, especially in the local vehicle assembly and manufacturing for the Ministry of Industries. I'm a national organizer for the Sri Lanka Automobile Service Providers Association, which hosts about 600 plus SMEs. And of course, I'm an advisor to the Automotive Service Providers Academy based in India. So that's a bit about me. And I'm just going to run through the high level of becoming a chartered engineer. So, to become a chartered engineer, you need a few key aspects. Number one is the knowledge and understanding in the engineering discipline. I'm not going to go into much detail about it. I'm sure, as engineers, you can learn about all of these skills on UK spec. Number two, B, is design development and solving engineering problems, which I'm going to go into detail later on in my slides. Next slide is going to be responsibility, management, and leadership. Again, another key element, which I will go to in a bit more detail about how I achieved that in my life. And D and E, D is communication and interpersonal skills, which everybody needs, regardless of whether you are in engineering or in any other discipline. And of course, the professional commitment. I'm sure all the panelists here, it's part of their this thing as well in terms of professional commitment. So if we can, without delaying, I'll straight away move on to design development and solving engineering problems. So in my life, I told you that I work for McLaren Mercedes. In that, there was something called root cause analysis. I think every engineer needs to learn and know about root cause analysis. So there, a few things that I can talk about. Coating related issues. So we painted carbon fiber composite materials. So there were so many problems that comes up with painting carbon fiber composites, which I can't tell you exactly what the problems are because certain things are covered by NDAs. And of course, on the automotive realm, there are electrical and performance errors that comes up in the automotive. So everybody needs to understand how to find the root causes and find solutions and stop it from happening again. And of course, when you go into root cause analysis, something that you need to do is, you need to re-engineer the product or the process or the material. And most of the time requires you to redesign as well. And a very crucial component of that is tracking and quality control. I'm going to talk about the design, product re-engineering, and the quality control in my next slide. But before that, another thing that I learned in my stint at McLaren Automotive is the manufacturing processes and streamlining, which is very important as an engineer. You need to understand quality control, regardless of where you are. So ISO standards is very important for anybody to understand and for you to implement in your work, in your companies. So something that I've implemented at McLaren is TS 16949. You can read up a bit more about it and applicable quality standards in your domain. And of course, another great thing that I learned about is new vehicle development. So something, when you're developing a car, you need to understand who is going to buy this car, what are the technologies that are going to use it, what is the price point of the product that you're going to build on. So many things that you have to look at. You can't just go and build a space rocket and make it work the next day. There is a lot of hard work that you do not see behind the scenes, many years of hard work before you can have a product going out to the market, which again, I can't talk too much from my experience, because of NDAs, but I can give you a high level, idea about it. If you can go to the next slide, please. Yeah, so when I told you about tracking, now, as you can see, this window is from Windows XP. So we developed these systems on tracking defects and the products using barcode readers, and legacy system softwares. So, these are, early 2000s that I developed with the company. And of course, there are more modern technologies. There's IoT now. You need to read up and implement these modern technologies in your work areas. So this is something that I have done. You can see the barcode reader we have coded to handle our work process, and the software that goes ahead with it. So, anybody can just get in touch with me later on, if you want some explanation or any advice, it can give you out. If you can go to the next slide, please. Yeah, so I spoke about quality control and ISO standards. So on here, I'm just showing you one particular stage of this thing. So this is part of the paint process documentation that we built for the McLaren Mercedes SLR, and a key document. We had about thousands of these documents, which I had to develop for the company in order to achieve the ISO standards. So it's very important that you are able to create documentation and make it, in a way that anybody could understand and anybody could replicate the work that you want them to do. So it's very important that you do, your documentation and learn these things. So if you can go to the next slide, please. Yeah. So moving on from there, I have another business called Cure Technologies, where we design and develop two-wheel vehicles. So when we are developing such vehicles in a country like Sri Lanka, we have limited resources, we have limited technology by way of equipment and tooling. We have issues with materials. So, we can't go to town and build a product that Europe or America or any other country would develop with a lot of technology. Because, as in a country like us, we are low tech. So as an engineer, you need to be able to work with low technology to deliver the same output, right? And another key thing now I showed you earlier on, which I developed using barcode readers and legacy system software. So with that in mind, after 15-20 years from that initial conceptual idea, I've developed a blockchain. I'm using blockchain technology, as in we are the first company in the world, in my opinion, in the automotive realm, to use blockchain to improve traceability, as well as to automate certain processes that doesn't require specialist knowledge or acumen. So if you can go on to the next slide, please. So as I told you on my previous slide, you can see the first column on your left-hand side, the die pressed parts. That requires anybody to spend about $10,000-15,000 on one die, and the equipment to make that component pressed out in a minute or two. But whereas when the volume is low, and when you do not have the money to buy the dies and the molds that is required, you need to improvise as an engineer. You need to find ways around it. You need to solve a problem. So if you can see, we have achieved the same problem through our design. We have designed it in a way that we can develop it with low technology, and at the same time we can change the design as we want, when we want it. So we don't need to produce million pieces just to break even on the die and the mold, because we are using something like laser cutting and the straightforward benders to develop it. So if you can understand, the progression of this from the die cast to the locally produced part, I'm sure, you can have the same output with low technology as well. So do not ever be ashamed to use low technology, because, you need to make money for the company. You can't just spend money as well. At the same time, you need to be practical about it. So if you can go to the next slide, please. So again, you need to look for the future. You can't always go low technology as well. Certain things that like software is where I'm good at. So as I said, blockchain, if you want, you can read out about it. You can depending on where you are and what you're doing, you can use it wherever. So with blockchain, our product, what we are doing is we are giving traceability in a global sense. We are reducing the labor and other costs through going digital. We are reducing paper costs, right? And most importantly, we are not held back through legacy systems where you need a desktop computer and a massive server to run your software. And simple thing as a mobile phone is enough for you to launch your product and your system. So if you can go to the next slide, please. Yeah. So again, on C, responsibility and management as an engineer, it's very important that you develop your team as well as develop your own self. You have to always remember the team is as powerful as you, and you are as weak as your team, right? So sometimes in a team you will come up with multi-ethnic, multilingual people. So you need to actually be, you need to find ways of communicating with them, maybe through hand gestures, maybe through drawings, maybe through images. If language is a barrier, you need to find ways as an engineer. Of course, it's very easy regardless of the language that you're talking with. It's Hindi, Tamil, Sinhalese, English, Dutch, French. Engineering is a universal language. As an engineer, you need to be able to converse with everybody around the world. And of course, social responsibilities. I think the four speakers in this and the host, we are actually, doing something back to the society, right? So me as a person, I have started something called Fair Trade Auto to give an equal pay for the lower level service providers, the spare parts suppliers, the painters, the mechanics, the technicians, the NVQ level people. So it's not just about the engineers. You have to look after the engineering technicians as well as the supply chain. So make sure that your social responsibilities are aligned with your values, with how you are brought up. And of course, as a part of that, I myself has taught many competitors of mine on how to become more financially productive and which technologies that they need to use, right? And of course, you need to be able to develop cross-border industries. You need to connect with different communities and help each other develop itself. You need to understand upstream and downstream development. So you're part of the ecosystem. If the ecosystem does not develop, you yourself would not develop. You need to understand that. So as part of the responsibility and management, I believe that you take away these three things and showcase as engineers that you have this knowledge. If you can go to the next slide, please. So I'm coming to my last slide here. So from my personal journey, I'm going to tell you something. I was rejected from the first preschool that I was the first preschool my parents applied me for. I was just about 4 or 5 years, right? So I did not get into that school, but later on I got into it. So I was rejected there, and then when I was doing my advanced levels, I couldn't do my advanced level because I got poor grades, and somehow I got to do it without delaying it, and I passed all within a few months. And of course, I got rejected from doing information technology, an IT degree, and that led me to become an automotive engineer. For me to sit here and talk about my past experience in a nutshell to all of you. So you always take rejections as part of your life and always make it, a fuel to drive your passion. And of course, I would not also be here without the guidance of my father. So again, for you as well, with your parents, with your teachers, with your peers, make sure that you have the guidance. And of course, you need to have a bit of luck as well. A bit of, I believe all these rejections in my life has given me the luck to be the successful person that I am here today. So all in all, when I applied for my chartered engineer professional registration, there's something called RPA, right? Somebody called RPA. So that's an advisor. When I applied, the people who are in my locality did not want to assist me to become a chartered engineer. I need to tell that out in the open, so that all of you would understand that it is, getting a charter is not that hard. If you go through the UK spec, everything is self-explanatory. You can read it by yourself and understand. You just need to match your experience and your knowledge with the UK spec. Go through each and every line, just like the previous presenter did. Go through each and every one and list down in bullet points and make your application. And of course, being professionally recognized, professionally registered can take you to lots of places. And once you're registered professionally, I would assume that each one of you, I think there's about 90 people registered here, that all 90 of you would at least build one chartered engineer in your life. So that is one humble request of mine. Thank you very much. If you can go to the next slide, please. So these are my contact details. If somebody wants any advice, any help in getting registered professionally, do give me a message, send me a message. I may not answer straight away, but I will reply to as much as possible and as quick as possible. So lastly, what I just want to say is, be registered, do your part. This is not something, very hard. You are engineers and you can do this. Thank you very much.
Thank you very much, Bravit. That was indeed an eye-opening presentation. Basically the personal experiences of yours as well. You just took it through. Actually, a really good take on how to approach it. I think when I actually invited you to speak, I was inspired by your LinkedIn post of when you actually got chartered, registered, and that's one of the reasons why I thought of contacting you as one of our speakers today. Thank you very much once again. And yeah, stay tuned. We have questions from our audiences, but not before our last speaker for today. Next, without further ado, I would like to invite Timothy Arkane for the final speaker for the session today on C-Cube. Timothy, over to you.
Good evening all, and thank you to Shyam and the IIT London Network for inviting me to do this presentation. I have been looking forward to it. So today I will tell you in brief about nuclear fusion, power converters, and chartership applications. So let me just get my Zoom link up. One moment, please. Okay. Okay, very good. Thank you. That's better. That's better. I can see all that. All right, thank you. On the left here, we've got a photo of me. This is me in Swindon.
Sorry, Timothy, for interrupting. We can still see your screen. Hope you're sharing the right screen.
You can still see that. You can see.
No, we can't see any screen. Oh yes, it's. Yeah. Now I can see you on the left.
Very good. Engineers are good with technology, right? Okay. Let's go back one then. Okay, today I'll tell you about nuclear fusion, power converters, and chartership applications. On the left here, we have me when I was 19 on the first day of my first, proper job And then on the right, we have, I guess, about 7 years later, me on the day I received my chartership. And this will be a short story of the years in between and how I got chartership, how you might too, and some fun with nuclear fusion along the way. So brief career history. So that photo in Swindon, that's when I started work at the Engineering and Physical Sciences Research Council, which was at the time the main UK government funding body for research in engineering and physical sciences. Then I went on to do a Bachelor of Electronic Engineering at Cardiff University, which I had a great time, and also played lots of volleyball. During that time, now actually in I think my first month of university, I applied to the IET Power Academy scheme, which is a scheme based in the UK for to attract more people into power engineering by giving them an annual bursary and annual summer placements at a sponsor organization or company. And that company for me was the UK Atomic Energy Authority, which is the main UK government organization for nuclear fusion research. Okay. Then I went on to do a master's in power electronics, machines and drives at the University of Manchester for 1 year. After that, I went back to that sponsor organization, the UK Atomic Energy Authority, or UK AEA. I stayed with them as a graduate electrical engineer for 1 year. Then I applied for a promotion a bit earlier than I expected, after 1 year instead of 2, and became a power system project engineer. 6 months later, I was headhunted by Tokamak Energy, which is a smaller private company engaged in nuclear fusion research with a view to eventually commercializing a nuclear fusion reactor. And I've been with Tokamak Energy for 2 years now as an electrical engineer. Okay, so what I mainly work on now is the design, procurement, installation, and operation of power converters for nuclear fusion. So to make nuclear fusion in what we call a tokamak here. So here we have the ST40 tokamak, we call it at Tokamak Energy. To make nuclear fusion in a tokamak, you need strong magnetic fields to force the atoms to smash together. And if you need strong magnetic fields, you need strong electric currents in the right shape and strength, etc., in all of these different copper coils you can see on the image. So if you haven't worked with power converters much before, if you imagine that a plug socket in the UK and many countries around the world has 240 volts AC in it, and because of the reasons of battery chemistry, you need 5 volts DC to charge your phone continuously. Then if you imagine that we might start with 3-phase 415 volts or 11,000 volts or 33,000 volts from the grid, and we want to make a small pulse of nuclear fusion, and we need, say, 100,000 amps DC for 200 milliseconds in one of these copper coils, then in between the grid and your tokamak, you end up with a very expensive phone charger. So that's what I mainly work on now. And so how do we get there, and how does that relate to a chartership application? Okay, so the first time I looked at this list of competencies is probably when I was a graduate, 6 months after graduation. And thankfully at the UK Atomic Energy Authority, they were really good, and they had a really good formal mentoring scheme. So every 6 weeks, I was assigned a mentor, and every 6 weeks or so, we sat down and he said, what have you done about chartership application? Have you been researching this? So probably about 6 months after graduation, sat down and looked at these competencies. And to be honest, it was pretty daunting. There's 19 categories there, and you've got to write evidence for every one. And you cannot get chartership unless you tick practitioner in every one. So that was the challenge, and perhaps we have some of you on the call here, perhaps you're quite far in your careers and you're looking at that and you're thinking, yeah, that's great, I can do that. I just need to write it down, which is a big challenge in itself. Perhaps we have some of you at various stages in your careers, and much like I was thinking, was looking at this list and thinking, okay, well, some of them, that's quite related to my current job, that's good. But some of them is quite outside my current job, and that's going to be quite challenging to fulfill that evidence. And thankfully, so I would really extol the values of a mentoring scheme. Thankfully, this sort of guided my development plans. At UKA, you had to do an annual development plan. I think our first speaker, Amit, shared one of his development plans in his presentation. At UKA, you had to do that once a year. You had to discuss it with your line manager, and that was a great career tool, and I would really recommend it. And even after your chartership, the IET requires you to do continued professional development and record these things. And the process of making a chartership application for me has really guided the first 3 years of my career, because I was having these conversations every 6 weeks and thinking, okay, well, I'm not doing anything towards this competency right now. What do I need to do? So I've got these projects and they're relevant, but what do I need to do? So we'll carry on, and I'll tell you sort of what I've done since I first looked at that, what the major projects were, and then how could they relate to a chartership application, and how could you think outside what you typically do, what the core of your job is, to some of the extra bits around the edges, and how could they help you tick all those boxes. And what does chartership mean to me, mean as an engineer, and what does it mean to have all these competencies, and how is it relevant to your life? How's it relevant beyond chartership? Okay, so back to university. So first month, I like to say that nuclear fusion plucked me from the cradle. All right, in my first year of university, I applied to the IET Power Academy, and the next thing I knew was for 4 summers during university, I was working at UKAEA. And I will never forget the first day that I went round for my interview there, and I saw some of the scale of the technology there. So pictured here is being constructed in sort of the early 1980s, is one of the largest energy storage devices in Britain. It's an 800-ton flywheel. And because the Joint European Torus, I think what is probably now, I think, one of the largest operating nuclear fusion devices in the world, because that requires so much power, close to a gigawatt of power for a very brief number of seconds for a plasma experiment. Because it requires so much power for a short window, it can't take that directly from the grid. So these flywheels are charged up half an hour before a fusion pulse, and then the energy is rapidly extracted from them during that pulse. So in my university studies, I learned about motors and generators, and I was very thrilled to have the chance to actually climb around inside one in the summer. And I went on to write my master's thesis based on these machines, on modeling them and with a view to replacing their aging voltage control. So that was university and IET Power Academy, and it was great because I got an early sort of connection to the IET and thoughts about chartership. And if you're watching this sort of 30 years into your career thinking, I finally need to do my chartership, that's great too. It's not a rush. Okay, so after university, then went to be a graduate electrical engineer there, shortly followed by power system project engineer. And my sort of biggest project during that time was around the power supplies for the diverter. So on the right here, we have a photo of the mega ampere spherical tokamak upgrade, or MAST-U. And what's special about this device is that if you see in the sort of bottom and the top of the machine, you've got a kind of X shape. This is called a super X diverter. One of the challenges in nuclear fusion is that a lot of the heat from the fusing plasma ends up smashing into the tiles around the base and the top of the machine. And the super X diverter is a concept to spread that heat load over a wider surface area. And you can just about see in this at top and bottom, you can see it from the cross section, about eight copper coils, 8 top and 8 bottom, that can very closely control the magnetic field shape in that area and spread the load over the wider surface area than previous designs. And so what you had as a result from those 8 copper coils is you had a sort of rapid flow of energy to and from the coils to their power supplies. And I wrote some of the, I modeled it extensively, and I wrote the control code for dissipating that flow of energy so they wouldn't overcharge a capacitor bank where they were stored during experiments. So I think we had project number 1 was my master's thesis on the flywheel generators, and the sort of major project 2 was the control code for the diverter power supplies, and then project number 3 was the commissioning of those power supplies as well. So okay, so you know, year and a half after graduation, I've done some work, done some commissioning. It's involved different teams, done some modeling, some coding. So, you know, I'm starting to have a bit of evidence, and then as a result, then lockdown hits, and all of a sudden I finally find time to write some more chartership application. So I think it's sort of week 3 of lockdown, and I start writing quite a bit, and actually write a first draft. I think, yeah, year and a half after graduation, and I send it off to my mentor and one close colleague that I worked with, who sort of got his chartership 1 year previously, and I said, could you have a read of that? And that's what I'd really recommend to anyone to looking into the chartership, is to seek out someone who might be able to mentor that application. And what you'll find is that you know, people are actually often quite pleased if you ask them for advice about your application, if you ask them for mentoring advice, is people actually feel quite honoured. And then since I've got my chartership, then I've had the same experience where someone has asked, a colleague has asked me for help with their application, and it's an honour. It's an honour, and it's something that people are often proud to do, so don't feel afraid to ask. So the feedback that I got from those 2 people I sent the application to was, it's okay, you might just about scrape through, but you know, 1 year and a half after graduating university, you've got you know, the evidence is a bit limited. And so I thought, okay, fair enough, I'll wait some time, and then I'll build up that evidence a bit further. So then I became an electrical engineer at Tokamak Energy, and I worked on a different tokamak. Here we've got SD40, once again, mainly on the power converters. And a year later, I had a couple more projects replacing aspects of those power converters, project managing a team of electricians to replace them, thinking about a lot of the safety aspects of that, operating the power supplies during plasma experiments, and all of that added experience, that operational role, that sort of project management, and sort of further technical modeling analysis work meant I had a bit more evidence, and I submitted the application. Now would have been June a year ago. So then took about 6 months till I got an interview. And luckily during that 6 months, had a bit more evidence during this role, had another major project that sort of gave me some additional info for the interview. And as a result, I got chartered in April, so very recently. All right, now, So my brief from Xiam was to focus a lot on competencies D and E. So we've got communication and interpersonal skills and personal and professional commitment. And if you're like me, where maybe your jobs and your interests have sort of started with quite maybe individual technical projects, you might find this the more challenging section. If you have sort of less technically complex projects but involve people and communication and ethical issues right from the start, you might find the reverse. So let's go ahead. I'll discuss a bit about this. So for D1, I think we've got, so communicate effectively with others at all levels in English. So I've got here a photo of me operating the ST40 tokamak, and here we've got the BBC's climate editor interviewing me. Okay, which is a great resource if you're trying to communicate effectively with others at all levels in English, because it's going out to the public. And so definitely take any opportunity where you've got that kind of public engagement to do this. Now, this actually happened after I submitted the application, but before the interview. So it was a good resource for the interview. But before that, what I used to do is I used to volunteer to give tours of the tokamak when I was at UKAEA. Took some school groups around, took people, members on the public on open evenings, and really enjoyed it, and sort of really good added experience. So you might find in your work, you give presentations to your colleagues, you might find you give presentations to senior management. Excellent evidence for communication and interpersonal skills. If you give any kind of public engagement outside of that, then that's an added bonus, definitely. Then let's think about D3, okay? Demonstrate personal and social skills and awareness of diversity and inclusion issues. One of my surprises from the interview was that the interviewers focused quite a lot on this competency, and quite a lot in particular on diversity. So probably almost 10 minutes out of a sort of 1 hour interview. And it's something I've really thought a lot about. And it's something particularly when you have opportunities like is shown in this photo, is to think, how do we represent this profession? And are we inspiring the next generation, all of the next generation, towards this profession? I would say that is something sort of all engineers now, particularly if you're applying for professional registration, is, we have a responsibility to take a proactive action on diversity and inclusion. So that's competencies D and E, that's D. Now let's have a look at personal and professional commitment. So step one, I would say, is read the IET rules of conduct. And then step two is read the Engineering Council's statement of ethical principles. And I think my answer for E5 was very much structured directly around the photo on the right: honesty, integrity, respect for life, law, the environment, and public good, etc. And this is one of my favorite aspects of how the Engineering Council and how the IET approach chartership, is that to be a professionally registered engineer is to have a chance to give back to society and to uphold the status of engineering in society. And the interviewers focused quite a lot on this. So what I found was, so sort of E2, we've got manage, apply, improve safe systems of work. So now working on high energy power supplies in nuclear fusion, that was relatively easy to apply, to supply evidence of. Understand and comply with relevant codes of conduct, particularly if you work in a heavily regulated industry like nuclear power, that was relatively easy to comply with. Then what you find is E5, ethical issues that may arise in their role. Now, this is where you've got to sort of reflect, and you might think initially, I can't really think of that, but then, you know, it might come to mind, okay, well, we had that discussion about safety, or we had that discussion about how we tendered for a contract, had that discussion about how we selected a supplier, and did we do that fairly? Did we do that with integrity? And or I was challenged, or I saw this behavior at work that I didn't agree with, and or how did I deal with that? And that's where it sort of takes some reflections outside the normal J job to think, okay, where have I found an ethical challenge, and where have I felt the need to be a responsible engineer? Okay. Lastly, I think we've got E3, understand the principles of sustainable development and apply them in their work. It was relatively tempting working in nuclear fusion to say, okay, I work in clean energy research, so that all counts. But you know, obviously that the interviewers weren't just satisfied with that. You know, I had to have some examples of where I did, in particular, where did I do something different? Where did I do something that I made a conscious decision to try and do something sustainably? Did I reduce material usage? Did I avoid wastage? Did I avoid the use of our energy, our sort of high energy consumption for nuclear fusion in a way that was trying to reduce our carbon footprint? And there's lots of opportunities around that. So to conclude, so got about 3.5 years after graduating university, I got chartered. I'm in the very early stages of seeing any impact of this in my career. Probably the first biggest impact has actually been this webinar and the opportunity to do this, which is really enjoyable. So thank you very much for inviting me. And I hope over the years to come that there'll be lots more results from this chartership, and it'll be very worth it. So thank you to everyone to organising it and tuning in. That's all from me.
Thank you very much, Timothy. Yes, you are right. We have got another 83 chartered engineers coming our way, I think, after RC Cube event. So if I may also request our other participants and my co-host to on their cameras and audio. In fact, we all are chartered engineers today in this event, the C-Cube. Most of the questions, great questions. Thank you so much, our audience, for great questions. We have a couple of more questions which have come up. I think most of it has been already answered by Amit and Ravit, in fact. But I think a recent question from Olusoji Lawrence. I think I'll ask you, Tim, your take on it. Right, so I'm a member of IET. I joined as a mechanical engineer, but I am currently with an oil gas servicing company. I just want to know if I can combine the projects in different industries for my CNG application. Also, can I contact you to support during the application process?
Okay, for myself?
Yes, Tim.
Yeah. Okay, can you combine the projects in different industries? Yes, definitely. So a couple of devices. So I use evidence from 2 different jobs in my application. When you select the supporters to your application, it's important to select people that have seen that evidence. So you might need to contact someone from your previous industry or your previous employer if you've used a lot of evidence from that, and ask them to support your application. So I had one supporter from my role at Tokamak Energy and one from UKAEA. So yes to that question. Can you contact me for support during the application? Yes, I welcome this, but I do have sort of limited time. So if I get a lot of messages, I might direct you towards contacting a professional registration advisor via the IET, which is open to all, I believe.
Right. One of thanks team for that answer. I think that sums up. Yes, you can combine different experiences. I think one of the misconception was actually questioned by one of our audiences was if we actually need a master's degree in order to attain a chartership or a bachelor's is enough. I think Amit, you responded that. Do you have anything more to add on to it for
Well,
other audiences?
thank you for passing it on. Actually, many people, they sometimes get confused with that, saying that they need a master's or even further education or even I heard saw a PhD also asking the same. Mostly, it's actually it's since it is related to more into industry. Just the bachelor's might do with the right amount of experience as long as you satisfy the subclauses of the UK spec. And also, even though if you are not a bachelor's degree holder, you can still apply for TMIT. And then in the due course of a career, you might apply for apprenticeship where you work in, you study in part-time and then you work in your main continue your work. Like it is just quite the opposite of internship, as you call this apprenticeship, and then they climb up the ladder towards, after completion of the bachelor's, move on to convert the TMIT, this technician member, to MIT, and then apply for chartered. It's not always required for memberships actually. Sorry, masters actually. So yeah, but it is a good reason to pursue masters in case if you're willing to relocate to UK, trying to access the UK market in engineering. In IT, it's actually different. People are getting lucky, but in engineering, it's actually very stringent securing or reaching out the market in UK. And they don't actually, they have to justify the government through a labor impact assessment before they can recruit from outside, that they don't have the skills inside UK. So in that
Right.
perspective, pursuing masters can be helpful.
That's right. Yeah. Absolutely. I mean, that's a good advice. In fact, Abdul Wasi has actually questioned: can undergraduate with 14 years of experience be eligible for a chartership, and how many years of CPD is required to put in place? Ravit has actually given him a really good answer. I think it's if you could explain a bit more on to our other audiences as well, we'll be really grateful for that.
Yeah, just to explain a bit further on that, it's not about the number of years of competency. It's how well you know and fit in yourself into each one of those competencies. So you might have only one week of experience. If you have mastered that competency, that is what is being looked at when you're becoming a professional, because at the end of the day, what is required of a professional engineer is to provide a practical and a pragmatic solution to any problem that you come across. So you have to be a practical engineer. So it's not about the years, but it's actually the practicality of that particular competency.
Absolutely. Now that's a great answer, Ravit. Thank you so much for that. I think I'll have a couple more questions. Timothy, if you could answer Hannah Brown. I have worked in a lot of different teams over the past couple of years, so it could be impractical to draw so many different sources of evidence. Could I maybe provide a mentor that has a knowledge of the work I've done instead of someone who worked directly with me? What's your take on it?
Okay, in terms of selecting supporters to your application, I think you can have maximum 2 or 3. I can't remember exactly. So in that way, you should select maximum 2. Yeah. So you should select supporters that have the most knowledge of your most significant evidence. Let's say the work you've done that you've used in multiple examples in the evidence. That would be my advice, was pick the most significant 2, and you'll find that the interviewers question all other aspects of the evidence as well. Yeah, and that's okay.
Absolutely. Thanks, Tim. Another one, an anonymous attendee. So they are member of IIT of MI and could apply straight to CNG. I have 35 plus experience, but do not have a degree. Is this a requirement, or can I rely on my experience? My experience should fulfill the requirement for CEng, is what they think. So, Robert, if you could tell me, do you really need a degree? I think it's a repeated question, but this is that they have just no degree at all. I think it's just the experience that they gain. So, what's your take on it, Revit?
Yeah, we'll go back a few thousands of years to answer this. I'll just go a bit behind. An engineer is a pragmatic person, a practical person. Degrees and diplomas came along in the last couple of centuries. So we have the eighth wonder of the world in Sri Lanka. Built so many centuries ago. It doesn't necessarily mean that you need to have a degree or a diploma. But of course, when you're going towards a chartered registration and becoming a chartered engineer, you need to adhere and you need to have a progression. So as Amrit earlier said, you can go and become a technician and then work yourself into becoming an incorporated engineer, and then from there show your proficiencies and competencies and become a chartered engineer. So I would not say no, but yes, you have to go through the process. It might take you a couple of years, but it's not impossible.
Absolutely not impossible at all. Yes, I take your advice on that too. Right, a couple more questions. I think we are almost on time. I think this one I'll shoot it to Amit. Will my supporter be contacted again during or after the interview? I think they're a bit skeptical on it.
Okay, actually, this is something that the supporter, since you're providing the contact number and email, they for verification, they always see that, for skill endorsement, what happens in the background. In my application, to be frank, I don't know whether my supporter was contacted in person by IET. But as far as I know, it's actually, since they're already a chartered engineer in IET, not outside IET. There are other chartered engineers as well, for instance, from Energy Institute. This is actually about IET. So you are getting your skills endorsed by someone who is chartered engineer from IET. Then they already know that this guy is a chartered engineer from IET, and then they will just contact them while verifying the details. I mean, internally, you would have forwarded your forms to the person to endorse it, and then it's just that. I don't believe that it's not after interview. I don't think so.
Thank you so much, Amit. I think we are almost done. The other questions we will you can contact us directly. You have our contacts are on our different platforms as well. So please don't hesitate to contact us if you have any doubts. As Timothy mentioned, we might not, Timothy and Ravit mentioned, we might not reply instantly, but when the time allows, we will definitely help you where possible. So to finish off with a couple of announcements and a takeaway, if you like, from today's speakers as well. So basically, this is the pathway that most of us will have to take. You have to have a recognized qualification, if not, as Ravit explained, a proper experience on your firm at all. Have an individual assessment done. It then goes on to sort of the step 2, which is where the professional review is being made on the application that you've made. It goes through a professional review interview as well later on if you are successful with the application. If you're not, it wouldn't be cancelled right away, but you would be sent out a proper explanation of why, and will be encouraged to reapply. So it's not the end of the world, but that's where the professional advisor actually helps you when it comes to IET. And after a professional review interview, when the panel has decided that you are capable enough to actually be a professionally registered chartered engineer, that is when you are being termed as a professionally registered engineer. So that's possibly the path step. But this pathway to professional registration it's not few months. It's not just 1 or 2 months, but it takes a good a good couple of months, probably even a year in my case, in many of our cases, to actually get the application done, because that's, as Timothy mentioned, it's a long process. You sometimes even get bored of writing more and more, but you just tend to write what is really on in a bullet point format, as many of our speakers explained today. So all these UK framework is what you need to demonstrate using the 5 different competencies that our speakers explained today, having the commitment towards all these 5 different competencies. So I would like to say thank you so much. And please do remember, as all of our speakers mentioned today, it's never too late, or it's not too late to start at all. You can apply, you can start application today. The support is all around you. As many of our speakers mentioned, just ask. If you need help, please do ask. Don't hesitate to ask. Our IET membership page, so that's the professional registration page for our IET. You will be given access to a career manager where you can record your CPD, where you can record your different competencies that you need to achieve in order to get the chartership, and that's what IET gives you. So if you are willing to take your chartered engineership application, please do go forward with the IET, is what I would recommend, though there are several other organizations that gives you through the Engineering Council. A couple of announcements. So we have Meet the Engineers Volume 2 Series 6. It's going really well, where you get an opportunity to meet the engineers in all these industries. We have data scientist versus engineer. It's on the 21st of July, next Monday. Please do tune in for this event. Thank you once again. Thank you for your questions, audience. Thank you for your participation. This event is organized by the IET London Young Professionals Network. We do such impactful events. We do personal developments, teamworks, and we also do fun social. So please don't hesitate to contact us, if at all you are a member of IET. You can also contact me if you wish to join our team. There's our followers on social media, the Twitter, Instagram, LinkedIn, Facebook, wherever you can find us. This C-Cube Chartered Engineers Career Chart will be posted in YouTube for any of your friends to have a look and find what to do in order to get to chartership. I once again thank you very much for your participation today. Thank you, speakers. Without you, it wouldn't be so much fun. And I wish everyone a wonderful evening. And this is Shyam signing off. Thank you.
Thank you, Shyam. Thank you. Same here.
Thank you.
That's right, guys.